This video introduces and walks through the build process for a new large diaphragm circuit upgrade kit for the MXL 990. The circuit kit is called the 990XF. This is a new product for us in 2021. This circuit kit contains everything you need to build a very nice replacement circuit for the MXL 990. This circuit, unlike the original circuit in the 990, is what we call transformer coupled, which means there is an output transformer that all the audio goes through on its way out the microphone. With this kit, we are also introducing two new large diaphragm capsule options, currently named the RK-47C and the RK-87C. Both of these are true 34mm large diaphragm capsules. They are fixed cardioid capsules, which means they have no metallization on the rear diaphragm. So they are going to work in cardioid only, not multi-pattern. This circuit kit is also cardioid only. This is a true K47 style. You can see single backplate. This is a K67 style, two backplates, and the drilling patterns are what you would expect them to be. But the voicing, maybe not so much. This is more of a vintage, sort of a darker K47 voicing. And this is the flattest K67 that I have ever seen. This is in fact a capsule we've been developing for a long time, and we're excited to be bringing it out now. This circuit does not provide any high-frequency EQ. Okay, there is no corrective EQ, no roll-off, no de-emphasis in this circuit. Normally, we would not recommend a K67 capsule with that circuit. But as I said, this particular capsule is voiced to be very flat, with just a small presence rise around 10K. So this capsule works very nicely with this flat response circuit. This new circuit was designed to fit the MXL 990, which is a very popular, inexpensive microphone. You can find these new or used for between $30 and $100. This one is clearly used and a little beat up. If you are shopping for a microphone specifically for this build, you can buy a microphone that is dead and no longer working, because if you are replacing the entire circuit and capsule, then it doesn't matter if the original microphone worked or not. Some people ask me, what would be the point of buying a microphone only to replace the capsule and the circuit and basically the entire signal path inside of it? And the reason is that DIY affords you the opportunity to build a microphone that would compete sonically with something that costs a lot more. Also, this gives you the opportunity to explore different voicing options in service of the goal of building sonic diversity into your microphone collection. We are introducing two new capsule sounds with this kit, but we already had two others that are also compatible. So that gives you four distinct voicing options within this one microphone. Those of you who are subscribers to the Mic Parts mailing list or to the Mic Parts YouTube channel might have seen me do a live streamed build of the 990XF just yesterday, in fact, as I record this. And the microphone that I built in that live stream is the one that I'm using for this voiceover right now. The live streams are great for Q&A. We had a good turnout. They're great for community building, but as permanent pieces of documentation, they are a bit lacking because that format encourages shortcutting some of the process. I would rather show a tutorial video that focuses on all of the process, but blazes through the repetitive stuff like soldering 15 resistors or whatever. So this video will cover all of the material that you need in detail. Now, this video is not intended to replace the documentation that comes with the kit. All of the kits that we make come with very good printed documentation. The documentation walks through the process step by step with full color photographs and calls out things to pay attention to. However, it can be reassuring to see someone perform the actual steps. So that's what this video is about, a supplement to the printed documentation. So here we go. This kit contains everything that you need to build the complete circuit. We do a process called biasing to each of these transistors. That means testing each one and selecting the bias resistor that gives each JFET its optimal performance within this circuit. In some cases, your package, your JFET package will have two resistors in it, in which case you would use the one whose value is written on the piece of paper. If you purchased two of these kits, do not dump these out because you'll have no way later to identify which bias resistor goes with this transistor. So keep these packaged until you need them. The only tools needed for this first step are a magnifier and a pair of needle nose pliers. You'll use the pliers to bend the leads before insertion into the circuit board. Any magnifier will do. I like this one because it has a light in it. So we sell these on the website if you need one. The first part we install is called the diode. It's a Zener diode. Looks like this. Now, diodes are polarized, which means they can only be installed one way. See the black stripe at one end of that? That will be lined up with the white stripe in the silkscreen on the circuit board. We need to bend the leads. What we want to do is bend them so that the part number can be read after installation. So we grab the lead with the needle nose pliers and put a 90-degree bend in it, like that. And then we can find its home on the circuit board. You can see how I've aligned the black stripe on the diode with the white stripe in the silkscreen of the circuit board. That tells us that the diode is installed in the correct orientation. Here's a shortcut to bending the lead in the right place. We can mark where that bend would be on the lead. Then when we come in with the needle nose pliers, we know exactly where to go. Line up the stripes. Ideally, your diode would be sitting down flush on the surface of the circuit board. It's not critical that it does. If you bend the lead too close or too far, you'll find it standing up. In any case, you do not want to smash the part down to make it sit flush, because if you try to smash this down, it will probably break the diode and then the microphone won't work. If you are working on a bench like this, you can simply invert the board and have gravity hold the board down against the diode for soldering. If you are using a circuit board vise, you could cover the diode with a piece of low adhesive blue painter's masking tape to hold the diode in place so that when you invert it in the vise, in space like this, the diode won't fall out. For soldering, I strongly recommend the use of a fume extractor. Before soldering, we clean and tin the tip of the soldering iron. Next, we trim the leads off. Always cover this with a finger or point into a discard bucket to prevent the loose piece of wire from shooting across the room. The next step is to inspect the solder joints to make sure that they are complete. You want to see solder that flows around the entire solder pad. The next step is to bend the leads of all of the resistors that we need. We can take the bias resistor out of the JFET pack. We'll leave the JFET in there. This is the 1 gig resistor. We won't bend that one. As with the diode, when we bend these, we want the value marking to be legible after installation. So you can see this one, 47K ohms. We want to be able to read that after the part is installed. When resistors are taped, you need to be careful pulling off the tape. You don't want to exert pressure on the resistor body. Grip these leads near the tape and then pull the tape off. The next step is to place all the resistors. Always verify every value before installation. I recommend placing all resistors before soldering any of them. The reason for that is that it makes it easier to catch mistakes. As before, you will want to see all of these parts laying down flat on the circuit board. If some are standing up a little bit, it's okay. If you wish to adjust because some are standing up more than you like, you can do that. Just rebend those leads. Do not force the part down against the board because resistors can break. If you are soldering against the surface of your bench, just invert the board. Alternatively, cover the resistors with blue masking tape to hold them in place. In some cases, it can be hard to reach through this forest of leads to get to some of the interior solder pads. So it's fine to clip off the ones that have been soldered and then come back and solder the ones you can reach. The next step is, as always, inspect all of the new joints to make sure that they are complete. If you see voids, lumps, cracks, remove the solder and rework the joint. The next step is to install ceramic capacitors. There are 3 of these of 2 different values. If some of yours come taped like this, rather than pull them out and risk damaging the component, it's better to clip them off of the paper like that. Ceramic capacitors are not polarized. They can be installed in either orientation. The next step is to prepare the JFET. Because we bias all of these individually, the value in your package will likely be different. It is sometimes good to clean the pins of the JFET with some alcohol. These are new old stock JFETs, which means they're old and the pins have oxidized. With pliers, bend pin number 3 90 degrees to the right. This component is also polarized. The silkscreen shows the orientation of the shape of the transistor. When you insert this component, you do not want it to be soldered standing up high like this, because if it stands so high, it won't fit into the microphone. You can see that once the circuit board is installed, there is not that much vertical clearance left. So you want this to be sitting down. At the same time, you do not want this bent lead to be touching the surface of the circuit board. Okay, so something like that is just right. Next, we take the 1 gig ohm resistor, round over 1 lead. The bend should be close to the resistor body. Insert the straight lead at R2, and the bent lead can go into the hole marked BP just temporarily. We solder just 1 lead here. The next step is to install the feedback capacitor. This is a small ceramic capacitor, 6.8 picofarads. Bend one of the leads to about 90 degrees. Insert this at C2. That 3-way junction of R2, C2, and the JFET will be formed on an insulated terminal, not soldered to the surface of the circuit board. You can use a piece of tape to hold that capacitor in place. You may have noticed that R2 moved while I was soldering it. It's standing up from the board a little bit. That won't hurt anything. I think this would still fit within the vertical clearance that we have. But there is a technique for reseating components when they stand up too tall, and that is to gently push down on the top of the component while briefly reheating the one soldered joint. You do have to be careful to not hold the heat on that joint too long, because you risk that heat transfers through and causes a burn. Next, we install the output capacitor. If the leads are a little out of shape, they can be bent back into shape. This component is not polarized, but we do want to make sure that it is seated flush against the board. Next, we install the electrolytic capacitors. Like diodes, these are polarized. The negative lead is marked on the capacitor body with that black stripe. You can also notice that the negative lead is shorter. The circuit board shows the proper orientation. All 3 of these are oriented the same way. Before soldering, double check that you have them oriented the right way. Look for the polarity signs, the markings in the silkscreen on the circuit board. The stripes should all be aligned in the same direction. For these 3 capacitors, we will solder just 1 lead of each. The reason we do that is to ensure that these are seated flush against the board. These are the tallest components in the circuit, and you can see that they have moved. So we will use the same trick that we showed a moment ago to reseat them. Reheat the one soldered joint while pressing the top of the capacitor from below the board, then solder the remaining 3 leads. Next, we clean the bottom of the circuit board. Do this step now it would be much harder to try to do it later. First, inspect the bottom of the board to make sure that all of the soldered leads have been trimmed. You should not see any wires poking up out of the solder joints. Take a folded paper towel, wet it with solvent that could be 91 to 99% isopropyl alcohol or flux cleaner, and scrub the bottom of the board. It's best to wear rubber gloves during this to protect your skin. You may need to make 2 passes to make sure that you have removed all the residue from the bottom of the board. The next step is to install the input terminal. This provides physical support for the input joint. We form this joint in the air because it is running at very high impedance. Earlier we put the lead of the 1 gig resistor into the hole where this terminal will go. So right now what we'll do is gently move that lead back out of that hole. And then we take the terminal and we insert it into this hole marked BP. BP stands for backplate, and it is where the capsule wire will be connected to the circuit. Then we arrange these 3 flying leads to make contact with the exposed metal pin of the terminal. First one is this JFET lead. So we wrap it part way around and then clip off the excess. Next one is this feedback capacitor. So we can wrap that one part way around from the other direction. Clip off the excess. And the last one is this flying lead from the 1 gig resistor. So we don't want this loop to be too high in the air because we don't want the top of that to short out against the capsule deck, which is this metal plate here. Then we can just bend the end about like that. It's not necessary to wrap each lead around the terminal. Just making contact is good enough. Then we carefully, without severing that JFET lead, snip off the end of the 1 gig wire. So now we have all 3 of those flying leads on the terminal. We do not solder that terminal yet. The next step in the manual is to inspect the circuit board. This is the point where you would go through the photo in the book and the circuit board in front of you and make sure everything is installed in the right place, in the correct orientation. The next step is to install the transformer. It will sit down into the hole in the circuit board like this. It's held in place with zip ties. To strap one side down, push the slack through. For the side with the wires, we want to route those outside of the strap. So just gently pull these through without causing any strain and without pulling them out of the body of the transformer. Cut the transformer wires to about 2 1/4 inches, measured from the bobbin. Remove the insulation from the last 5 millimeters or so of each of the 4 wires. The easiest way to do this is with a wire stripper. Twist the wire ends together. The next step is to solder the primaries, which are the audio inputs. The manual shows exactly which wire corresponds to which solder pad. These are all well marked, and in fact they're marked on the top and the bottom of the board. If you did not twist the wires sufficiently, they might fray when you try to insert them. You could also tin the ends. When soldering wires, there are a couple of things to watch out for. One is that the insulation goes to or nearly to the surface of the circuit board, but not through it. And 2 is that the bare wire end did not splay out and have a little conductor that's reaching out to a nearby component, potentially causing a short circuit. If the insulation goes into the circuit board, that can cause problems because it can interfere with the solder joint itself. In the case of these transformer wires, the insulation is too big to fit into the solder pad hole, so not so much a risk here, but it can be a risk with the capsule wires. Now we can disassemble the donor mic. If your 990 has this piece on the bottom, that has to come off first. Unscrew the lower half of the body, remove that, and if the trim ring stays in place up here, take that off as well. The entire assembly is held together by 2 screws. You'll need a Phillips head screwdriver. Hold on to the screws and standoffs. You'll need those for reassembly. Clip the XLR wires right next to the circuit board. Clip the capsule wires. To remove the capsule, loosen these 2 screws. And then with a flat blade screwdriver, remove this plastic harness. You will retain this screw and reuse it. Now we will install the new RK-47C capsule. So this comes with a saddle to hold the new capsule. We will install it with the screw that we took out of the stock capsule. I recommend using a drop of thread locker on this screw. This helps prevent the saddle from working its way loose. The saddle that we include has 2 sets of mounting holes in it. The outer hole we'll put towards the front of the microphone. How do you tell the front of the microphone? The XLR 3-pin marks the rear. The saddle has alignment tabs on the bottom to keep it in the correct orientation. So you want to tighten that screw down well. And then if you did use thread adhesive, you can swab away the excess. This is the new capsule. We have pre-installed the backplate termination wire. So there are holes drilled around the circumference. So we just need to install the capsule ideally so that the diaphragm wire eyelet points towards the circuit. So you can see that by rotating the capsule, you can get it to line up with that hole in the saddle. The capsule comes with 2 small metric screws. When you're handling the capsule, you do not want to touch either the front diaphragm or the rear. Hold it by its edges only. Install that first screw only about halfway. That gives you some leeway on the other side to make sure you can line up the other mounting hole. The second screw can be tightened all the way, but do not apply so much force that you shear the head off of the screw. Then return to the first screw, tighten that down, and then for good measure, check that the blue wire eyelet is also tight. Route both wires through the holes in the pedestal. Then either take a picture or write down or remember which wire is which. You need to distinguish the diaphragm wire, which is the one that comes off the center of the capsule, from the backplate wire, which comes off what's called the backplate. Your wire colors might differ, especially if it's a different model of capsule. Then we can briefly, or temporarily rather, reinstall the head basket, which helps protect the capsule while we install the circuit board. So I'm putting in one screw and standoff just to hold that grill on top. Now we know this is the front of the microphone. We want to install the input joint towards the front. So we will be putting the circuit board in this way. And this circuit board is compatible with two different styles of 990. This one has the taller standoffs. This is about a 13 millimeter standoff. The circuit board would fit in this way. It also fits the 990s that have the shorter standoffs and shorter spacing. The standoffs in this version are about 7 millimeters, if I remember. And in these, you can insert the circuit board upside down. You might need to, probably will need to cut off the bottom of this terminal pin. Just be aware that it's a heavy pin and it could nick your side cutters. So don't use your best brand new side cutters to cut that pin. But you definitely do not want that pin making contact with the capsule deck later. Now we prep the XLR wires. We will trim off a bit of insulation from each. If your XLR wires look cruddy, you could replace them. In any case, you need to verify which wire is which. Most of these microphones will use the same colors, but you should not assume that your wire colors will match because the microphone doesn't care what color the wire is. It does care about voltage. In this case, XLR1 is black and XLR2 is red. Now, we will be inserting the circuit board like this. We will be soldering the XLR leads from beneath the board. The solder pads are marked underneath the board. One way to prevent these wires from fraying upon insertion is to tin the ends. So we'll do that now. This is an illustration of a common problem with tinning the ends. Sometimes too much solder builds up on the end, making the wire impossible to insert into the pad. So the solution is to trim off the tip. Whenever soldering on the top side of the circuit board, you have to be extremely cautious that you don't let the shaft of the iron, which is hot, touch anything that you care about. Now is a good time to clean these new solder joints. We will solder this front diaphragm wire first. The pad is marked FD. Now this is something to be careful of. This is a very fine wire and the insulation fits through the entire solder pad. If you solder the wire like this, it won't work. But even if the insulation is just peeking out of the bottom end, you could solder it and it still won't work. What you want to do is be careful that the insulation stops at the top of the circuit board. The grill makes a useful microphone stand for this operation. The last solder joint in the microphone is the most difficult and the most sensitive. This is where audio comes in from the capsule to the JFET. Take your time to prepare this. If the backplate wire has an exposed end, a bare wire end, clip it off, and then trim off 5 millimeters of insulation. Twist the individual strands of wire together, but do not tin them. Wedge this wire into the four-way input joint, that is, the bent lead of the JFET, the flying leads of the feedback capacitor and the 1 gig resistor, and the input terminal. If you have not tinned the bare wire end, it should be easier to wedge this capsule wire into that junction. Inspect this joint carefully. The solder must encompass all 4 of those active leads, that is, the capsule wire, the JFET lead, and the flying leads of the feedback capacitor and the 1 gig resistor. Furthermore, the solder must not touch the surface of the circuit board. While you're making the solder joint, do not hold the heat on for too long because heat will damage the JFET. Then we clean that joint. You can inspect it to see if you see any brown flux residue. Ideally, you would not see any after cleaning. At this point, the microphone build is complete. We can remove the grill so we can get the circuit board fully installed. And if you've purchased an upgraded grill, now would be the time to install it. When we put the circuit board in, we want to have it sit on top of these little pins, and we want to try to tuck in all of these wires. The standoff sits between the circuit board and the bottom of the capsule deck. Then line up the other end of the screw with the hole in the capsule deck and the threaded hole in the grill. At this point, we can apply phantom power and do a voltage test. The most critical point to test is the JFET, what's called the source and drain, which are marked on the bottom of the board. Those are the 2 legs that are soldered down onto the circuit board. So we have phantom power applied. We put our meter into DC voltage mode, like that. Attach the black lead of the multimeter to the mic chassis. Actually, let's do it this way. Then we take the red probe and we touch it to a single point. Never let the red probe bridge 2 other points because that would be a short circuit and it could damage the microphone. Also, when you do this kind of test, you want to mute your audio output because this will cause all kinds of noise to come out your speakers. So here's the source, 1.11 volts, and here's the drain, 4.8 volts. That's very, very good. We can also test XLR2 and XLR3 if you are so inclined. We already know the microphone is very likely working. So here's XLR3. And if you don't get a reading there, it could just be that there's some flux or maybe some melted insulation preventing the tip of the probe from making contact there. So you can always probe the solder joint on the other side. There we see 46 volts, and then the same, or very close to it, with XLR2, just like that. XLR1, of course, is grounded, so this is going to be 0 volts. Now, a common fault in this build is if you connect XLR pin 1 to either the XLR2 or XLR3 pads, then the microphone will not work properly. The next step would be an audio test. You can do that now. The mic will hum because the body is not installed. The body is required to shield the circuit and the transformer from EMI RFI, that's electromagnetic and radio frequency interference. But what we can do is sort of hold our hands around the microphone like this in order to provide shielding. And I can see the meters on my mixer working, so I'll turn this on. You will hear the hum. So now you're hearing the hum and you're hearing this microphone. But if I shield it, that should be better. It may not be perfect. When we put the body back on, then it will work much better. But that's the new microphone. The next step is to finish the assembly just by screwing the lower half of the microphone body on. I will also mention at this point that you could paint or powder coat the lower half of the body. If you do, mask off this recessed top area, because you need this to make contact, electrical contact, with the chassis in order to provide good shielding. So here's a quick demo of the mic that we just built, as well as the same mic with the other capsule that we're introducing with this kit. So what you're hearing me through right now is the 990XF with the RK-47C capsule. And then I'll switch over. Now this is the same circuit with the RK-87C capsule in it. And so the difference between these two mics is honestly not that well demonstrated by my voice, which is somewhat frequency limited. It doesn't have a lot in the very lows, doesn't have a lot in the very highs. But even so, I think you can hear the difference. So here's the 47 again. What you're hearing here is 1 to 2 dB more happening in the mids, meaning 3 to 5 or 6 kilohertz. Maybe a dB more in the deep bass, below 80. And then this one has a much softer top end, above 8 or 9 kilohertz. And now when I switch back to the 67, this again is a little bit leaner in that mid-range band, 3 to 6 kilohertz or so. A tiny bit leaner below 80 or 100. And then this one has more air, more presence above 10. And it's not because the capsule has a giant boost up there. It's just that it's more extended than the 47, which is kind of rolled off in that range. So for my voice, I think this mic, the 47, is better suited, but other sources would be very different. Acoustic guitar, drums, anything that has a wider frequency response would benefit from, potentially benefit from the 67 more than my voice would. Anyway, that's a quick demo. I hope you enjoyed the build. If you are building it, good luck to you, and certainly let me know if you have any questions or comments. I would appreciate feedback on the manual. And if you do get stuck, drop me an email. I'm happy to help out. That's it. Thanks for watching.